In this video, we will discuss the turning points of polynomial functions and a strategy for graphing polynomial functions. First, we're going to look at this example. f of x equals x to the fifth minus 6x cubed plus 8x plus 1. As you can see in the drawing of this graph, the graph has 4 smooth turning points. This equation has 5 as its greatest exponent and is therefore a polynomial function of degree 5. Since we know the graph has 4 turning points and 5 is our degree, in order to determine how many turning points there will be in a polynomial function, you would use n minus 1, where n stands for your greatest exponent. So now let's look at strategies for graphing a polynomial function. First, we need to do the leading coefficient test to determine n behavior. Then we need to find the x-intercepts. If k is even, the graph touches the x-axis and turns around. If k is odd, the graph crosses the x-axis. If k is greater than 1, the graph flattens out near r0. Then we need to find the y-intercept. Use symmetry to help draw the graph. Y-axis symmetry, f of negative x equals f of x. Origin symmetry, f of negative x equals negative f of x. Then use n minus 1 to check whether it is drawn correctly. So here's an example. f of x equals x to the fourth minus 2x squared plus 1. The leading coefficient, 1, is positive. The degree of the polynomial function, 4, is even. Since the degree 4 is even, the graph has the same behavior at each end. The leading coefficient 1 is positive, which means the graph rises to the left and rises to the right. Now we need to find the x-intercepts. So we look at x to the fourth minus 2x squared plus 1 equals 0. We factor it. X squared minus 1 times x squared minus 1 equals 0. X plus 1 times x minus 1, x plus 1 times x minus 1 equals 0. X plus 1 squared times x minus 1 squared equals 0. X plus 1 squared equals 0, or x minus 1 squared equals 0. So x plus 1 equals 0, which means x would be negative 1, and x minus 1 equals 0, which x would be 1. We know it's a multiplicity of 2 because it occurs twice. X plus 1 occurs twice, x minus 1 occurs twice, so it's a multiplicity of 2. Now we need to find the y-intercept, where we put 0 in for x. f of 0 equals 0 to the fourth, which is 0, minus 2 times 0 squared, which is 0, plus 1. So f of 0 equals 1. So our y-intercept is 0, 1. We take the degree 4, subtract 1, which gives us 3. So that means there will be 3 turning points. So let's graph this. Our x-intercepts are negative 1 and 1. Our y-intercept is 0, 1. Now our end behavior of our graph rises to the right and to the left, so our graph will look something similar to this.